Hi class, we continue our study in chapter 1 talking about linear equations and linear functions by now moving into section 1.5. In this section what we want to do is we want to talk about if I give you certain information, all right, incomplete information, I give you, you're ultimately going to need to know two things. If I give you two things, and those two things are basically going to be, I'm going to tell you the slope of a line and the point it goes through, how you can find linear equations or the equations of lines from that information. Okay, there's a bunch of different ways you could do this. Actually, there's two. I'll show you both of them, um, and we'll work some examples. Then we'll also bring in parallel and perpendicular lines in this video as well. Okay, so first off, let's talk about just an example of using slope and a point to find an equation of a line. So I can't stress this enough. You want to make notes of this as you're watching the video or taking notes, that if you want to find the equation of a line, okay, an equation of a line is that y is equal to mx plus b. You need to know two things. You need to know the slope of the line and any point it goes through. All right, so let's start. Let's find the equation of a line that has slope 3 and it contains the point or goes through the point 2 comma 5. All right. Well, first off, we know the equation for a non-vertical line can be put in this form. Y is equal to mx plus b. All right, so what you need, okay, is always when I say find an equation of a line, you need to put it in this form. Y is equal to the slope times x plus b. And if you remember b, that's the y-intercept. All right, so here's the thing. We know what the slope is. We know that the slope is 3, so I can put that literally right into my line. Okay, so this is what we have. Y is equal to 3x plus b. So all I need to do now is I need to find b. I need to somehow find the y-intercept. Well, this is some point 2 comma 5, right? That's not the y-intercept. The y-intercept would be something like 0 comma something. All right, so to find b, recall that every point on the graph of an equation represents a solution to the equation. All right, so in particular, this ordered pair 2 comma 5, okay? What that means is when x is equal to 2, so if I were to plug 2 into here, y would be equal to 5. So this should satisfy this equation. Well, look, I have an equation here, right? There's three variables, y, x, and b. Well, I'm telling you when x is 2, y is equal to 5. So if I plug in 5 here and 2 here, all I'm left with is b, and then I can solve for b. All right, so what I'm doing now is I'm plugging the 2 in for x, the 5 in for y. 3 times 2 gets me 6. I'll subtract 6 from each side, and I'll get negative 1 is equal to b here, because 5 minus 6 gets me negative 1. All right, so what I'm doing now is, well, great, I know what the y-intercept is. I know that b is equal to negative 1. So I'm going to substitute negative 1 in for b in my equation that I had going back here. So I know b is negative 1. So in y is equal to 3x plus b, I've now got this y is equal to 3x minus 1. All right, so you can use your graphing calculator to verify this if you want. Let me show you this. You can use the trace on your calculator. I'm going to show you another tool just so you can see real quickly. So loading up the graphing calculator here. First thing I'm going to do when you have your graphing calculator loaded up is I'm going to hit the y equals button. I'm going to plug in 3x minus 1. All right, I'm just going to hit graph so you can see what it looks like. This line looks a lot like this. You can use trace. Trace isn't always particularly great because it won't give you exactly the 2 and the 5 here. But if you see this thing called table, I'm going to hit second function table. Look, it's telling me when x is equal to 2, y is equal to 5. So I did find the equation that has that solution. All right, so this is what I did. I gave you a point and the slope. I plugged the slope in for m, and then I used the point for x and y to find what b was, and then that gave me the equation of my line. All right, let's do another one. All right, so let's find the equation of a line that contains these 2 points, negative 2 comma 6 and 3 comma negative 4. All right, remember what I said. I said you need to know the slope of the line and any point. Well, here I'm just giving you 2 points. I'm not telling you what the slope is. Well, it turns out that you can find the slope, right, from any 2 points on the line. So this will be my x1, y1, x2, y2. So it's y2 minus y1. So minus 4 minus 6 gets me minus 10 over x2, 3 minus x1 minus 2. So minus minus becomes a positive. 3 plus 2 gets me 5. Negative 10 divided by 5, well, that gets me negative 2. All right, so here's the thing. We know the slope of the line. Okay, so remember, take your y is equal to mx plus b and plug the slope in, which is negative 2, in for m. All right, now I've got to find b. All right, both of these are points on the line. So I could pick either one of these points and plug it in for x and for y. All right, since the line contains the point, I'll pick the second one, 3 comma 4. I'm going to substitute 3 in for x and negative 4 in for y. All right, just like this. So negative 2 times 3 gets me negative 6. I'll add 6 to both sides here. Negative 6 and positive 6 cancel out. Minus 4 plus 6 gets me 2. And that's my y-intercept right there. So now all I have to do is substitute it back into the equation. So I had y is equal to minus 2, which ended up being the slope, plus b. Well, I'm telling you b is the y-intercept here. So my equation is just y is equal to negative 2x plus 2. You can use your graphing calculator to check this. So just like I did in the previous example, if you plug this in, this equation into the graphing calculator, you'll see that both these points are indeed solutions to the graph. Right? And I'll just do that for you real quick just so you can see. I'm going to go into my y equals. I'm going to clear this out. I'll plug in negative 2x plus 2. So you got to go negative 2. Don't put the minus sign. Use this negative 2x plus 2. I'll graph it. You can see this line looks a lot like this. When I look at my table, I see that negative 2, all right, gets me 6. And then down here, 3, when x is 3, y is equal to negative 4. So both those points are on this graph. So I found it perfectly. Okay. Let's just go over real quick how you can do this. All right, so finding a linear equation that contains 2 given points. All right, so to find the equation of a line that passes through 2 given points whose x coordinates are different, okay, because if their x coordinates are the same, it's just a vertical line. All right, you use the slope formula. All right, the m is equal to y2 minus y1 divided by x2 minus x1. So the first thing you do is you find the slope of the line. Always, always, always. Then you substitute the m value you found in the first step into your equation. This y is equal to mx plus b. So I've got m in here now, replaced with the number. I'm going to take one of the coordinates from the given point. All right, from the given points in the equation. Doesn't matter which one. Both will work. Both will give you the same solution. Always pick the easier set of values, though. And plug them in for x and y and get b. All right, so now after I've done that, I've just solved for b. So you're going to substitute the m value found in step 1 and the b value found in step 3 into the equation. All right, so you're going to get your y is equal to mx plus b now. And then finally, if you want, you can use your graphing calculator to check that the graph of your equation contains the 2 given points. Always, always, always. All right, let's do some parallel and perpendicular stuff, some harder ones. Okay, so find the equation of a line. So I want to find the equation of some line we'll call L that contains this point, this 5 comma 3, and is parallel. Okay, so it's parallel to this line. All right, so notice how this line has a y-intercept. A parallel line, what do we know? A parallel line will have the same slope, but a different y-intercept. All right, so for the line that's given, the y is equal to 2x minus 3, we know the slope is 2. So the slope of the parallel line that I'm looking for is also 2, because parallel lines have the same slope. So an equation of the line L is y is equal to 2x plus b, because they have the same slope. Now to find b, I substitute the coordinates that were given, this 5, 3, into this equation. So I'm going to take 5, plug it in for x, 3, plug it in for y. So I get 3 is equal to 2 times 5 plus b. 3 is equal to 10 plus b. Let's subtract 10 from each side. The 10s go away. 3 minus 10 gets me minus 7. So my equation here is y is equal to, well, remember the slope was the same, so it's 2x minus the y-intercept you just found, so minus 7. So y is equal to 2x minus 7. So we can graph this to verify, and I have the graphs displayed here, but I'll show you. I'm going to go to the y equals, I'm going to clear out. So my first was 2x minus 3. My next one was 2x minus 7. And when I graph, you can see the two lines right there. So remember this bottom line, right, had to contain the point 5, 3. Right, so when I go back in y equal, look, the bottom line is 2x minus 7. So when I go to the table and I go down to x is equal to 5, well, the second line is telling me y is equal to 3. So 5, 3. So it does contain the line, or the point that we're looking for is on that line. So that works out. You can rely heavily on your graphing calculator here to help you as needed. Okay, then we've done parallel lines, same slope. Let's do a much harder one. All right, let's talk about perpendicular lines. So find an equation of a line L that contains the point 6, negative 7 and is perpendicular to the line minus 2x plus 5y is equal to 10. All right. Well, let's isolate this equation here. All right. Notice how it's not in the y is equal to mx plus b form. So let's isolate y in this equation. So the first thing I'm going to do is I'm going to add 2x to each side, so these cancel out. I get 5y, I'm going to move the 2x in front is equal to 2x plus 10. I'm going to divide everything by 5 to get the y by itself. And this is what I have. Y is equal to 2 divided by 5x plus 2. All right, there's a fraction in it. No problem. That's okay. We'll deal with that in a second. All right, so this is the slope of the one line that we have. We're looking for the line that is perpendicular to this line right here, perpendicular to this. All right, so for the line y is equal to 2/5 x plus 2, the slope is 2/5. All right, so the slope of line L must be the opposite of the reciprocal. So perpendicular lines, their slopes are negative reciprocals. So I'm going to take positive 2/5. I'm going to flip the fraction, and it becomes 5/2. And then since this was positive, I'm going to make it negative. All right, so the slope of the perpendicular line that we're looking for, all right, is negative 5/2. So an equation of L here is y is equal to minus the slope I have of the perpendicular line is minus 5/2x plus b. All right, well, look, the perpendicular line contained this point, 6, negative 7. So what I'm going to do now to find b is I'm going to substitute the coordinates of the given point, 6, negative 7, into the equation. All right, so I have y is equal to negative 7 is equal to minus 5/2 times 6 plus b. If you've forgotten how to multiply fractions, that's okay. You can do a quick review, but just you're going to take the top number and multiply it by this. All right, so you get 5 times 6 is 30, then divided by 2. So 30 divided by 2 is 15, and then it's negative, all right, because your negative doesn't go away. So I've got negative 15 plus b is equal to negative 7. So I'm going to add 15 to both sides, and negative 7 plus 15 just gets me 8. All right, so the equation I have is y is equal to, the slope was minus 5/2 x, and then the intercept I just found was 8. Okay, you can plot this in your graphing calculator, and let me do that for you so you can just follow along and see. All right, so I'm going to go back to y equals. I'm going to have to clear out both of these. The first line that was given, when you have fractions, you're going to have to put them in parentheses. So 2 divided by 5, close the parentheses, x plus 2. And then the line we just found was negative, and then in parentheses, 5 divided by 2, x plus 8. So when I graph it, here was the given line, right? And this is the line we found, the perpendicular line, that I plugged into L2, okay? So now what we said here is it had to contain the point 6, comma, negative 7. So if I go into my table, and I go down to 6, when x is equal to 6, yes, indeed, the line contained negative 7. All right, so that worked. All right, I like this method for finding the equation of a line. What I want to do is just show you another method that you can use. And this is what's called the point-slope form of a line. So if a non-vertical line has slope m and contains some point, all right, we'll just call that point x1, comma, y1, then the equation of the line is you take y minus y1 is equal to m times x minus x1. Right, so whatever the line is, the point is, excuse me, you plug it in for x1 and y1, and you plug the slope in here. Then what you can do is you can simplify it to get to that y is equal to mx plus b. All right, so let me give you an example. All right, so a line has slope m is equal to 2 and contains the point 3 comma negative 8. Find the equation of a line. All right, so what I'm saying here is x1, you're substituting in x1 is 3, and y1 into the equation is negative 8, and the slope m is equal to 2 into this equation. So when you do, watch what happens. You get y minus y1, so minus 8, is equal to 2 times x minus x1, which is 3. So simplify here. Double negatives become positive, so y plus 8, distribute the 2, so you get 2x minus 3, 2 times minus 3 gets me minus 6 here. So the next thing I'm going to do is I'm going to subtract 8 from each side. So these 8's cancel, and you get y is equal to 2x minus 6 minus 8 gets me minus 14. So notice how I didn't have to do like the plug the x and y in to solve for b and then go back. I just took it, plugged it into this form, and then simplified. So you could use your graphing calculator to check this, and let's do that real quick. So I'm going to go into my y equals. I'm going to clear out all this stuff. So the equation I found was 2x minus 14. Shoot, I put it into L2. Sorry about that. Go up to L1. 2x minus 14. The graph of this looks like this, all right? So I'm going to look at the table. When x is equal to 3, right here, y is equal to, you can see, negative 8, which I have right there. Perfect. Worked out great. All right. So let's use this point-slope form of an equation to find a line that contains these 2 points, negative 5 comma 2 and 3 comma negative 1. Then I want to write the equation in that slope-intercept form. Slope-intercept form is that y is equal to mx plus b. Well, I give you 2 points, right? If you remember what I always said you need to find the slope. All right, so first you find the slope of the line. So you take this, you take y2 minus y1, so minus 1 minus 2 gets me minus 3, right? Then you, x2, which is 3, minus x1, so minus 5 gets me 8. So I have minus 3 divided by 8. Doesn't simplify at all, so this is just minus 3/8. So this is the slope. All right, looking at these 2 points, this one is the easier one. So let's just use this. So I'm going to look, my x1 is 3, my y1 is negative 1. So x1 is equal to 3, y1 is equal to negative 1, and my slope, all right, m is minus 3/8. into this equation. So y minus y1, so y minus minus 1 is equal to my slope minus 3/8 times x minus x1, which is 3. All right, fraction, no big deal. Let's simplify this. Double negatives become positive, so this is y plus 1. When I distribute the minus 3/8, all right, so minus 3/8 times x is just minus 3/8 x. Minus minus becomes positive, okay? So this is plus. Remember to multiply the top. 3 times 3 gets me 9, and then the 8 just goes here, the bottom, right? So you're just left with 9/8. Now what you have to do is you have to subtract 1 from each side. All right, these ones will cancel. Now, when I subtract 9/8 minus 1, how did I get this 1/8 left? Well, you need common denominators here. So the denominator here is 8. So I'm going to change the 1 to 8 divided by 8, right? Because 8 divided by 8 is still 1. So now when you subtract fractions, you go 9 minus 8 is 1, and then you leave the denominator here, which are common. 8 is just 8. So the final form here is y is equal to minus 3/8 x plus 1/8. I know the fractions are a little tricky. Trust me, I know. But if you practice with it in your homework, it'll be pretty easy. And you can always ask me any questions.